Good afternoon, all. I thank all the participants who have shown keen interest in participating for this webinar on GRIHA for large developments. Now, let me introduce all of you to the speaker for this presentation. Mr. Apurvij is working as the Program Manager Technical in GRIHA Council. He has been working in the field of GRIHA rating and green buildings for over 7 years. Enthusiastic and competent professional, he has been spearheading expansion of GRIHA rating framework portfolio and its implementation with GRIHA rating, with SWA-GRIHA rating and GRIHA for large developments. His core strengths are expertise in green buildings, adoption of innovative approaches to routine the projects and implementation of the rating framework. He spearheads development of the new variants for GRIHA rating systems and their subsequent revisions. He has also actively engaged in design and review of the IT tools required for the GRIHA, including the website tools and the smartphone app. The GRIHA smartphone app is the India's first green building app. He conceived and operationalized the GRIHA product catalog, a process for actively engaging with green building industry. He is actively involved in training of building professionals and increasing awareness for the green buildings pan-India. Participants can send in their questions through the chat. We'll be replying to all the questions that you'll be asking through the chat or through Apurv at the end of this presentation. Now I'll request Apurv to please take over from here. Over to you, Apurv.
Right. So welcome to this webinar on GRIHA for large developments. GRIHA stands for Green Rating for Integrated Habitat Assessments. It's a green building rating system developed by TERI for Indian working conditions and endorsed by the Ministry of New and Renewable Energy back in 2007. GRIHA for large developments is the rating system that GRIHA Council developed to address specific challenges and green rating of projects bigger than 50 hectares of site area. And today in the webinar, I'll be taking you through briefly what the rating system is all about. So brief update of GRIHA before we move forward. There are currently, as we speak, about 600 projects registered with GRIHA across India. And when I say GRIHA, I mean all three variants of GRIHA, which is SWA-GRIHA, GRIHA rating, and GRIHA for large developments. GRIHA for large developments itself has about 10 projects registered. In the previous version, of course, the version that I'll be talking to you about today will be version 3. So coming straight to GRIHA for large developments, GRIHA LD is, in short, is applicable for all projects with site area equal to or greater than 50 hectares, or in other words, 125 acres. Any project with a site area equal to this much can apply for a GRIHA for large development rating system. Benefits of GRIHA LD rating. 1, branding and recognition of the environmental performance of the entire development. The rating gives certain recognition to the environmental performance that the development has executed. The rating addresses fundamental issues around development through carbon footprint analysis, carrying capacity, etc. It's a consolidated environmental performance evaluation system. The project team can actually use the rating system to understand what is the design, the environmental design that they are executing on site, and then they can monitor the actual performance against the projected targets that they have set for themselves. It is flexible in approach. The intent of developing GRIHA for large developments in the manner that we did was to focus on macro level parameters, to focus on the large numbers, and allow complete flexibility within those to the project teams to make their own choices about how they wanted to address those parameters. And lastly, it's designed for future modifications in local regulations. Now, when we talk about large-scale developments, we talk about a time duration of 10 years, we talk about 15, 20, 25 years at times. Now, the building bylaws, etc., would, of course, undergo several changes in next 25 years or even 15 years. Therefore, in LD, what we have done is we have kept the rating of each phase independent of each other. Therefore, whatever are the future modifications in the building bylaws or regulations, the project teams can use those modifications and take a rating of those phases which will come up at that point of time later. And it does not hamper or affect the rating achieved by a previous phase. So each phase gets rated independently. A key concept of GRIHA LD rating is self-sufficiency. This is the core ideology behind developing the rating in the manner that we did. GRIHA LD lays emphasis on concepts of net zero energy, net zero water, and net zero organic waste. So briefly, if I summarize this, the idea is before any construction is happening on a site, the site is not exerting any pressure on energy, water, or organic waste resources. The site does not need any energy, it does not need any water, and it's not generating any waste. But once the development comes up, the development requires a certain amount of energy to function, certain amount of water, and it will generate certain amount of organic waste. The concept here is to bring it as close to self-sufficient as possible, to reduce demand and to be self-sufficient. And that's the basis on which the entire rating has been developed. Focusing on broader aspects, instead of going and establishing multiple criteria, the entire rating has been split into 7 sections. Each section has some appraisals, but broadly it is the sections which dictate the overall points. So therefore, again, one is focusing on key numbers at the development level, and not going into minute detail of everything, because at that scale, broad numbers work. So the 7 sections of GRIHA LD are carrying capacity, site planning, water, solid waste management, transport, at LD level that's important, social, and energy. Social is also something that GRIHA is slowly focusing on, adding a component of social parameters in each rating system so that we constantly shift from being purely green building rating to a sustainable building rating system. So in addition to environmental parameters, a conscious decision is to keep adding socioeconomic parameters and keep shifting and pushing ourselves towards a sustainable based rating system. In each of these sections, the impact is calculated on 2 key themes. One is self-sufficiency and other is development quality. Self-sufficiency focuses on resources, and therefore only 3 sections have this component in them: energy, water, and solid waste. Everything else has development quality as the only parameter. Here are the subsections. As you can see, energy self-sufficiency, water self-sufficiency, organic solid waste treatment, site planning, energy, water, solid waste management, transport, and social. Each of the sections or subsections in the rating has been given 100 points, but each of these are not equal in cost, each of these are not equal in the environmental impact, each of these are not equal in the resource priority or the resource crunch that India has. Therefore, we did a survey of experts from the field and asked them to provide relative rankings so that we could then establish how important is one section or subsection compared to the other. And the result that you see in the green column, overall weights, is the result that it came up with. And therefore, each section is given 100 points overall, but then multiplied by the weights so that each section has a relative hierarchy. As you can see, the maximum importance was given to water, followed by energy, based on the resource priority that India is about to face. The rating scale is given here. That's the overall score. To get a 1-star rating, you have to achieve at least 25 points in the previous weights based on the parameters that you achieve. And the bandwidth is of 15 points each. So 25 to 40 gets you 1 star, 41 to 55 is 2, and so on till you touch 85 or above and you hit a 5-star rating. The rating of the project is done in 2 parts. One is the master plan rating, which means once the project is being conceived right in the beginning, a one-time rating to see what is the proposed self-sufficiency of the entire development once it's complete. But as I mentioned earlier, each phase gets its own rating based on actual construction. So the master plan rating can be taken by the project right in the beginning, say today, but say the project is split over 3 phases and the 3rd phase will start coming up 10 years from now. The requirements will change, the priorities will change, the bylaws will change, the amount of people you want to put on that piece of land will change, and therefore each rating, the rating of each subsequent phase is independent and will be evaluated at that point of time based on the parameters that are done for that particular. So let's begin with the sections. The first section, that's carrying capacity and carbon footprint. This is purely an indicative section. That means there are no points in this case, but we want to introduce this here because we wanted projects to start doing this analysis for themselves to begin understanding what kind of pressures are being exerted by the development. The concept is carrying capacity is the ability of a natural and artificial system to absorb population growth or physical development without considerable degradation or damage. So in a sense, when we have a barren piece of land and we do a construction on it, we do a project development on it, we start exerting certain pressures on that piece of land, and it can only sustain so much by default through recycling, etc., naturally, ecologically. So the analysis here is to see, are we within the carrying capacity of the land? Is the proposed development going to exert more pressure than the land can carry, or is it going to exert less pressure than the land can carry? So to do this, and to do this in a slightly simpler manner, because we've just begun the introduction of this in the ratings, we have taken and focused on 3 parameters only for carrying capacity right now. The first is carrying capacity of available water. Here, as you can see on the screen, for the project level, what we ask you to do is to look at the total water that's available to you, divided by the per capita requirement per day. This gives you the total population that can be supported on the site by the amount of water that's actually available to you. And if the population that can be supported on the site is greater than the population that you're planning there, that means that the people on the site, once the project is complete, will always have enough amount of water with themselves, and there'll not be a shortage, so to say, unless the supplies stop. So that's where this becomes very crucial to do in the beginning, to see, suppose on a piece of land, only 15,000 people can be supported. And if you are planning a project to house 18,000, that means there's a shortfall for 3,000 people's daily water requirement. And the intent here is to provide those indications to the project team. This section does not affect the rating, but the intent is to keep indicating that this is the kind of development that is being done. The next component is carrying capacity of green cover. This is based on a WHO standard. The WHO says in any large-scale development or city, every person must have at least 9 meters squares of green cover available to them. That means that is the minimum amount of green cover that you must have for yourself. So here, one is looking at total green cover, and you divide that by the project population, fixed population only. And if that is greater than 9 meters square, then you are doing a good design. That means every person will be able to will have a certain amount of green cover, which is over and above what the WHO recommends as the minimum standard. The green cover here is only canopies of trees and urban forests, playgrounds, jogging tracks, etc., paved parking and grasses in that are not counted here. Only tree cover and urban forests. And the last part of carrying capacity carbon footprint is, of course, carbon footprint calculation. So here we ask you to calculate the per capita carbon emissions, again, indicative, but an exercise that we want people to begin doing for their projects. So fairly straightforward. One, we take the total CO2 emissions from the buildings. Then we take the total CO2 emissions from transport. And the summation of that gives us the total CO2 emissions. Now, how do we get CO2 emissions from the buildings? You look at the total energy that is consumed by the buildings and site infrastructure. There's a section that will cover all energy, from where you can get this number. You multiply it by 0.81, which is the emission factor that we are considering here. It's based on the Central Electricity Authority report. And that gives you the net annual emissions from the buildings. After this, we look at CO2 emissions from transport. For this, there's a dedicated transport calculator that we built into the online documentation tool of GRIHA LD. You can simply input your minimum distances that people have to travel within the site. And depending upon that typology, it calculates annual CO2 emissions from transport and gives that number to you. So both these numbers are extracted from the tool, and based on that, you know the total CO2 emissions from the development. When we divide this total CO2 emissions by the total project population, we get the annual per capita CO2 emissions. And India's national average is 1.3 tons CO2 per annum per capita. So if the emissions are below this, that means the project is actually designing for lower footprint than India's national average. So in case a project constructs very pedestrian-friendly, walkable distance-oriented developments, and if they construct efficient buildings with a lot of clean energy sources, then that, of course, gets benefited. Moving on to the 6 sections and beginning with site planning and coming to development quality. Sorry about that. So the stormwater management is the first criteria, which is partly mandatory. And this has about 30 points. In this section, we're looking at 3 different things. First, ensure that the total stormwater management plan is designed such that post the development of the project, the peak runoff rate and quantity do not exceed the runoff rate and quantity from the last 2-year 24-hour design. This is mandatory. So essentially, the idea here is to ensure that because of the development, urban flooding should not start happening. So the peak runoff rate and quantity before construction should be met even after construction. Now this, for a 2-year 24-hour design, is mandatory. However, if the projects do this for a 5-year 24-hour peak design, that means a broader average, then the projects are given 15 points because that's a better design, that's a better initiative. So basic design of 2-year 24-hour, 2-year average 24-hour design is mandatory, but a 5-year 24-hour design gets points. In addition to that, incorporation of sustainable urban drainage systems, in other words, SUDS, into the stormwater management strategies to ensure that litter, solids, hydrocarbons, etc. are removed from stormwater fetches extra points. Essentially, in order to do this, the projects will have to design SUDS for the entire stormwater drainages so that the SUDS can take care of and filter the particles out of the stormwater. Just a brief information on what SUDS are. So as you can see in the image on the top, before construction on a piece of land, when there's a water flow, part of the water gets absorbed by the vegetation, part of it flows to a water body, and part of it gets recharged, goes underground. After construction, as you can see below, the runoff rate increases and the water goes out to the urban catchment at a faster rate, therefore causing the urban flooding. And the rate of recharge is also less because of the hard paving. The intent of SUDS, the SUDS are a sequence of management practices, control structures, and strategies designed to efficiently and sustainably drain surface water while minimizing pollution and managing the impact on water quality of local water bodies. So these are natural mechanisms to manage storm water. And if I can show you some examples. On this is one image. I think there's a slight lag between my system and the online, where you can see this drain in the blue line. These are trenching on a slope to ensure that because of development, extra water that flows around the slope, the speed of that water gets reduced and it gets channeled along the contour, does not flow down in one sheet flow, so it does not cause much erosion, etc. These are some of the strategies that are part of SUDS. Another one on the right, as it comes. Yes, so as you can see, there are multiple small water bodies that are there, and they are connected to each other so that overflow from one goes to the other, but each one also is a small shallow pond. They also help reduce the water runoff away from the site, and they ensure that whatever solids are there, they get settled down. So they treat the water as well to a certain level, and they also reduce the rate of runoff from the site. These are two examples, but there are many such strategies, and depending upon the site that you have, they would change. So inclusion of these is a crucial aspect. The next parameter is maintaining existing site features. Projects are awarded about 30 points for this. The intent here is to ensure that more than 25, 50 or 75% of the total site area under existing natural features on site, like water bodies, dense mixed species tree clusters, and very steep slopes with contours with slopes greater than 1:4 are preserved during construction and post-construction. Mind you, this is not 25% of total site area. This is 25% of the site area which is under these natural features. So it becomes very crucial to do the analysis accordingly. For example, there is this is one example from a large development project in Kerala, where they had a large water body in the on site, which they wanted to maintain as well to store rainwater. So they maintained this and designed the entire construction and development around it. This is another photograph from another site where in patches of land in between the entire site, they had these dense tree clusters, which they were maintaining, and they preserved and they designed and developed the construction around it. So these kind of strategies enable projects to reduce their environmental impact. Manage construction activities in a manner to reduce environmental damage. The intent here is to see that you do not disturb any natural drainages on site, and the site engineers have a construction plan through which they can ensure that the construction activities do not cause environmental damage. So they know how to manage construction on site. There is a proper staging plan in place so that they only execute construction activities on the site area where it is required, and not say flatten or clean the entire site in one go. The last part of site planning is tree and topsoil preservation. This is partly mandatory, and if the topsoil is not fertile, then that clause is not applicable. So the non-applicability clauses of GRIHA are brought forward in GRIHA for large developments. So first clause, which is mandatory, is total number of trees on site before and after construction should stay the same. So if you are cutting a certain number of trees, you should replant at least that much. But if you plant 25% more than those that existed before construction, then you're given 10 points. And if you reapply topsoil in more than 75% of the landscape areas, then again you are given 10 points. Mind you, this is 75% of landscape areas, not 75% of the site area. This is one example. I'm sorry, there's a slight, I think there's a slight amount of lag between my system and the online thing. So this is an example of topsoil preservation where, sorry about that. So as you can see on the screen here, on the right side, that's topsoil from a site that was being preserved, scrapped top 8 inches of fertile soil, taken out from the construction site and stored on site to ensure that it stays fertile and can be reused for landscaping purposes once the construction is complete. Coming to the next section, that's energy, and let's begin with self-sufficiency. The design the development to ensure at least 25% self-sufficiency. This is mandatory. That means a certain amount of self-sufficiency has to be built in. This can be done through energy efficiency and on-site renewable energy sources. Again, as I said, GRIHA LD is focusing on flexibility, so we do not mandate how much can be achieved through energy efficiency and how much through renewable energy sources. We just say achieve the 25% self-sufficiency, and the project teams can choose what is the balance between energy efficiency and on-site renewable that they would like to implement. Of course, the eventual aim is to see if the project can be designed to be fully self-sufficient, in which case that will be net zero. Now, the methodology to do this has two parts. One, demand reduction. First, design energy efficient buildings, energy efficient street lights, etc., so that you need to consume less energy as compared to the GRIHA base case. So the GRIHA base case EPI and the GRIHA base case for street lighting, which are there in the LD manual, are used here as base cases, and you have to design the buildings to ensure that your buildings are far more efficient than these, and that will start bringing in the self-sufficiency for you. Of course, please notice that all mandatory compliances are, as recommended by ECBC, are mandatory, and this is something that we think is important, and we've brought forward from the GRIHA rating. So design of efficient buildings like this is a GRIHA 5-star project, which reduces the overall energy consumption, is crucial. And the remaining self-sufficiency can be brought about through supply optimization. So generation of on-site clean energy. So when we say that we want you to be self-sufficient, people start thinking that we're asking you to put renewable energy straight away. That's not the case. We're asking you to look at demand side reduction as well as supply side optimization, both of them. And the balance is what one is trying to achieve here. And which, as I said, on-site renewable energy, this is from a project in Kanpur, and there they have on-site renewable. They're doing this in parts for the entire campus. Looking at the calculation, this is how actually the entire calculation is done for self-sufficiency. On the top, you have the design case. B1 is building EPI. EQ is equipment load. As you know, in GRIHA, the EPI does not include equipment load, but in LD, we take into consideration every unit that gets consumed on site. So we say building energy consumption, L1, L2 are street light energy consumption, and P are plumbing and utility energy consumption. RE is the on-site renewable that gets generated. So if you notice, B1 and B2 are different. B2 is the base case EPI. If your buildings are far more efficient than GRIHA, then B1 will be quite less. That begins your reduction. L2 is base case street lighting consumption. If your street lights are more efficient than the GRIHA LD base case, as you can see in L1, it will be different, and therefore reduction will happen. And the remaining will happen through RE. Their equipment load and plumbing and utilities do not have a base case in GRIHA LD, and therefore whatever you select in base case will go into design case. They will stay same in both of them. Coming to development quality, moving to outdoor street and security lighting. This is a mandatory clause. Outdoor street lights should meet the required lux levels. This is crucial from the perspective of visual comfort of occupants of the project in the night when they move about. This is also useful and important from security perspective, that all the outdoor areas, wherever required, have sufficient amount of light and are not dark. Also, additionally, automatic switching or dimming controls should be provided for all outdoor lights. Then we come to smart mini grids. This is something that we've introduced in GRIHA for large developments, where we say there should be an on-site, if possible, there should be an on-site smart mini grid, which can control and manage multiple energy sources. As you can see in the graphic below, on the leftmost column, you have multiple energy sources, which get managed through a central controller. As you can see, if I can move my mouse here, right there. That's the central controller. The controller keeps track of how much energy is required at what point in the project, and it keeps track of which energy source is generating how much energy, and it keeps managing what energy to use from which source automatically, which means the efficiency is drastically improved and the management is much better of energy. The wastages are less. So for example, if a project has renewables on site and it has a direct connection from the utility grid, then the controller can see how much energy is being getting from the renewables. It will use that completely, then see how much more energy is required by the project and take that from the utility grid. So it can do real-time monitoring and it can do this management automatically, which is an extremely important move now. So therefore, we have certain amount of points dedicated to smart mini grids. First, integration of various energy sources with prioritization to renewable energy sources should be done, which means the smart mini grid must on site first consume renewable energy and the balance should come from the utility grid. Real-time monitoring and control, even on mobile devices. So wherever you are, you can go online through your tablet, laptop, mobile phone, and look at what is the consumption numbers like, what is generation like. And a bit of demand side management is important. So in case the controller thinks there's a light fluctuation, it should be able to turn off water pumping, street lighting, etc., which is why we've written based on predefined criteria. So if there's a fluctuation, do X. In case there's a energy shortage, do Y, etc. Those should be built in. Passive urban design. Here one is focusing on adopting strategies so that the outdoor temperatures in pedestrian areas does not increase too much. And if you do a good passive design, then it should be reduced below the GRIHA LD base case. If I can simplify that again, because of construction, there's a certain amount of increase in outdoor temperature that happens. The intent here is to see how much can that outdoor temperature increase be reduced below the base case, and points are awarded accordingly. This is again a point-based analysis, and therefore we ask you to do this analysis over 5 outdoor common areas. Common areas would mean areas where people gather mostly, because we're looking at occupant comfort. And street layouts and buildings should be designed to provide minimum obstruction to local wind flows, except during unfavorable months. So in case you're in Delhi or in, say, Chennai, and you don't want a lot of wind flowing through peak summer months, but at any given point of time, otherwise you would like the wind to keep flowing, minimum obstruction on that. Coming to outdoor temperature, an example is this site where you have a lot of soft paving, you have trees, you have water bodies, all of which help mitigate the outdoor temperature. And the calculator that we have is designed to do this analysis. This calculator analyzes the effects of built environment over an area of 50-meter radius. And therefore, one suggests the project team to select at least 5 representative areas and do the analysis over there. The calculator develops its own base case to analyze how good you are. This calculator is based on the work being done by National University of Singapore on urban heat island effect. And the output of the calculator is something like this. So if you notice the blue column, it will tell you, based on your design, this would have been the increase in temperature in the base case. The green column tells you this is the increase for what you are proposing. And the purple column tells you this is the reduction between the two. So higher the reduction, that means better your design against the base case and better the points you get. So the more you design for outdoor temperature comfort, to be comfortable for occupants outside, the better the points that you get. This can be done largely through a lot of vegetation, because green cover does have a huge impact on outdoor temperature mitigation, and the massing and the percentage of hard paving that you have outside. Based on the sensitivities that we did, these are the key things that affect it a lot. Last component of energy is metering, operation, and maintenance. This is partly mandatory. So energy metering is mandatory. So basic meters at multiple sources to see how much energy is being consumed from the local grid. DG set, on-site renewable energy sources, that's mandatory. Sub-meters on each building, outdoor lighting system, and the campus pumping station, again, mandatory. There should be a constant log to see this is the amount of energy being consumed through each of these point sources. After that, if a project has a dedicated operational staff for O&M of all electromechanical systems, you get 10 points. If an operation and maintenance protocol is actually established and implemented, that's 10 points. It's extremely crucial to educate the operational staff with the protocol. And periodic energy auditing fetches another 10 points. That means every year, at least a basic audit, very, very basic, and tabulation of numbers should be done by the project teams. Then we come to water and wastewater, self-sufficiency, and there we say design the development to be at least 25% self-sufficient in the total amount of water required. This means self-sufficient against groundwater or municipal supply. See how you can capture water on your site, recycle and reuse it so that you are self-sufficient on site itself. 25% self-sufficiency is mandatory, but it is recommended to be fully self-sufficient as well. And interestingly, in GRIHA for large developments, out of the 10 projects that we have about 3 projects right now which are actually designed for 100% self-sufficiency of water, which is a very encouraging practice. So the self-sufficiency calculation looks like this. You have total water demand, which is the building water demand, domestic water demand, your landscape water demand, and all the water you need for utilities. This is the total demand that you have on site. You subtract what you are recycling and reusing, so recycled wastewater, and the captured rainwater that you are filtering and reusing. Whatever is balanced is the amount of water that you need from the municipal grid or groundwater. If this balance is 0, that means you're fully self-sufficient. If you are not reusing water at all, you're not capturing rainwater, and that water reuse section is 0, that means you're fully dependent upon outside. So here the intent is the mandate is to have at least 25% self-sufficiency, but 100% is recommended. This is one example from Kanpur again, where on the left, the images of the STP. This is part of the STP, of course, the STP was much bigger. And the lake that you see is a full water body that they made on site, which only has recycled wastewater connected to the irrigation system of the entire campus, so that the amount of water they need for irrigation gets reduced and they can be self-sufficient, at least on that front. So overall water balance isn't there right now for this, but this is one good example of how it can actually be done, and some projects which are actually coming forward in doing this. In development quality, the first becomes quality of water. This is mandatory, which means whatever water is being used at whatever source or whatever point in the project should meet the minimum quality requirements as per the IS codes. Water metering, so metering of main water supply, treated water, recycled water, rainwater should be metered. That's mandatory. Some metering of each building and some metering of the irrigation system is mandatory. The idea is that metering is a very crucial aspect, and it is important to conduct this in projects. That's why we made basic metering mandatory, and advanced meterings get points. An STP or wastewater treatment on site should meet the CPCB norms. So the project gets 20 points if the STP meets the CPCB norms. If the project recharges surplus rainwater through appropriate filtration measures, it gets another 20 points. That means you have surplus rainwater and you're recharging that after filtration. That's a good practice. However, if the Central Groundwater Board says do not recharge for your particular location, then this particular subsection, parameter is not applicable to you. All fixtures on site should be low flow fixtures. So as a blanket component, everything should be low flow. WC, urinals, showers, kitchen faucets. So it can straight away be looked at in a tender document, in a BOQ, that everything purchased is low flow. And the last one, remote monitoring, operation, and maintenance. So establish a remote monitoring and control system for the plumbing network. That's 20 points. Do periodic water auditing as well. That's 15 points. And establish an O&M protocol. That's another 10 points. In organics or solid waste, first we come to self-sufficiency. Treat all organic waste on site, kitchen and landscape waste. This is one example from a project in Dehradun, where they had on-site vermicomposting for the entire campus, and all kitchen waste or landscape waste was being brought here, converted to manure, and was being reused in the landscaping purposes. So something like this should be done for the project, treat everything. Coming to development quality, the first part that's mandatory is handling and treatment of special waste. By special waste, we refer to medical waste. So if there is a medical facility in the project, then on-site incinerators, autoclaves, etc. for treatment of that waste as per the bylaws, as per the guidelines must be there. Or if the guidelines say send it to a nearby treatment facility, then that provision should be there. That plan should be in place. And the second special waste is e-waste. So projects are required to have contractual tie-ups that eventually e-waste from site will be taken and recycled by certified e-waste recyclers. Both of these are crucial, important special waste, and their treatment is an extremely important aspect. Use of sustainable construction materials. This is something new that has been introduced in version 4. In your construction of roads, ensure that at least 5 or 10% of recycled waste is used. Most of the road construction, you can use recycled plastic, etc., or sometimes waste concrete from the site itself, so that's recommended. Reuse waste in construction of paving on site. So this could be broken bricks, blocks, etc. from the project itself, which can simply be reused on the pavements as well. And all cement in the project should be PPC, or if you're doing an on-site mix, then at least a 15% mix. Segregation of storage of waste on site. This is during operation. Provide hygienic secondary storage facility for organic and recyclable inorganic waste. That means people segregate waste when they throw it in different colored dustbins. At the project level, you should have a dedicated space where different wastes are stored separately. And once the wastes are stored separately, there should be contractual tie-ups with different recyclers who can purchase this waste from you and recycle it. Organic waste, of course, you would treat on site, but plastic, metal, paper, etc. can be sent to outside recyclers who can purchase it from you. But that kind of a tie-up should exist. This is one example of a recyclable waste room where all recyclable waste, so as you can see, cardboards, paper, etc., are stored here. Organic waste gets stored somewhere else. This kind of a dedicated space must be given at a project level. Construction and demolition waste management. Develop and implement a construction waste management plan. So that means during construction, site engineers know how to manage different waste, where to store it on site, how soon to clean it from the different building points and bring it to a consolidated space on the site, and adopt strategies to recycle and reuse this on site or off site. So if you're doing it off site, then a contractual tie-up with a recycler who is coming and taking it for recycling. If you're reusing this on site, then photographs, etc., of how that is being done on site. This is one example of construction material storage and waste management. Coming to transport, development quality, provision of footpaths and bicycling tracks, and safe interaction of non-motorized traffic with motorized traffic. This is partly mandatory. So firstly, all roads should have footpaths, sidewalks, and cycle tracks, mandatory. All footpaths, cycle tracks should be continuous, wide, and universally accessible. It shouldn't happen that somebody is using a footpath and walks on a road and it comes to a junction and suddenly realizes that after the junction there is no footpath. That means it should be continuous, it should be wide, and it should be universally accessible. These are important parameters for the success of these infrastructure facilities. Then, importantly, both of these first ones are mandatory. What are optional are the following. Supporting infrastructure and facilities like bicycle parking, landscaping, public convenience, etc. should be provided. That's 15 points. Having trees, places to sit, etc. are helpful in enabling people to use these kind of infrastructure facilities to walk, to cycle more. And there should be necessary physical safety measures like railing, etc., non-slippery surfaces, so that in case somebody thinks they are slipping, they should be able to hold on to something. This is not necessary throughout the footpath or cycling track, but at crucial junctions where one thinks that some sort of slippage is possible. So this is one example, of course, not from India, but as you can see, footpaths and cycling tracks, continuous, they slope down to meet the road, and then the person can go to the other side. This kind of design is crucial. So safe interaction of pedestrians and cyclists with non-motorized transport here. And as you can see in this one, in both the photographs, a lot of trees, benches, etc. So in case somebody is walking across the site, they want to catch their breath, they want to keep their back for a second, then do some work, take a phone call, etc. They have these conveniences which they can use. So all of these conveniences help in people using more and more pedestrian infrastructure. Road network planning. Take measures to ensure that the speed of vehicles moving across the site is controlled. This can be done through multiple ways. One is how you design the road network of site. If there are a lot of straight roads with minimum junctions, etc., then people will speed. However, if there are cul-de-sacs, if there are curved roads, then the speed gets limited slightly. Another way of doing this is by having speed bumps and breakers so that people constantly cannot go above a certain speed limit. They stay within control. On-site parking. So ensure that the total parking provided on the project site does not exceed the area required by the local bylaws, and provide dedicated parking space for physically disabled people as per the GRIHA LD guidelines. Running collective transport services on site. This is another aspect where GRIHA LD requirement is that run a basic collective transport service like a electric buggy, etc., for people to move within the site. So if people want to go from point A to point B within the site, they can use these kind of collective transport services. The intent is to shift people from their own vehicles, from private vehicles. And the other part of this is to connect the site to nearby public transport system, or have the city's public transport system run through the site so people can go to the city areas and back if the development is too far away. So intra-site collective transport system and connection to an outside public transport system. And last part in transport is electric charging infrastructure for at least 10% of the parking area. That means if people are buying a lot of two-wheelers and they're buying a lot of electric cars, etc., the infrastructure on site should be such that they shouldn't feel range anxiety. They should be able to go to a point and connect their vehicles there, go do their work, study, etc., come back out without feeling that they won't be able to get back to their home within the development, and they'll have to drag their vehicle there. So this is an important aspect, and this will help promote e-vehicles in the country. So this is an important thing that has been introduced here. The last section is social, where we start looking at, again, development quality. Facilities for construction workers. This is mandatory, and this is borrowed straight from GRIHA. All safety norms of National Building Code should be implemented during construction. All workers on site should have access to clean drinking water and hygienic toilets. And all accommodation facilities must be clean and hygienic with access to clean drinking water and toilets. And all child labor should be fully banned on site. All these things are mandatory. Multiple places where we've seen this, of course, in GRIHA, a lot of safety measures in project sites. Earlier, people were skeptical. Now we've started to see that this has become a common practice, so that's a positive thing. Clean drinking water for workers on site, and clean and hygienic, decent accommodation for everybody. Social infrastructure and development. Here one is talking about, one, design of development that should be done for universal accessibility, including provision of disabled-friendly public toilets. So in case you're designing a neighborhood and there are community centers, ensure that those have the required number of toilets, disabled-friendly toilets as required. Slopes, lifts, ramps, railings, etc. should be there as per the requirement. Second part is create environmental awareness through imparting information through display boards, panels, websites, etc. So you're constantly telling people how they can improve or reduce their environmental footprint, save energy, water. Next part is to identify tobacco and smoke-free zones on site. So there are areas where smoking should be fully banned, or the entire site if it is fully banned. And the last one, very importantly, provide dedicating resting areas and toilets for service staff. This is extremely crucial. Most of the time when the developments are done, when projects are constructed, the service staff, the drivers, security staff, maids, etc. are not catered to. Here one is looking at ensuring that they have a dedicated area where they can rest, dedicated number of toilets. Of course, a threshold has been provided by GRIHA LD. We did not want people to have a 50-hectare project and provide one toilet on it and say this is for service staff. So for that reason alone, we said there's a specific threshold and you must provide a basic number of these facilities as well on site. This is one example from a project in Uttarakhand where they had this kind of a hut, 3 of these based on the number of service staff that they had, and all 3 was positioned in different parts of the site. Each hut had one resting area with a fan and a desert cooler, etc. And the door that you see leads to the toilet here. And this is a dedicated facility. And this is another example of creating more environmental awareness. This is from a GRIHA project, of course, but initiatives like these where you're spreading the message on environmental awareness to more and more people, displaying positive case studies, etc. are crucial. Planning for low-income group population. This is when you're doing a neighborhood, a township kind of development. Of course, in an educational campus or an SEZ kind of development, this doesn't work. So therefore, this section is not applicable for educational campuses and SEZs. So the requirements are, 1, EWS housing on site should be provided. The health centers and schools there must be dedicated health centers and schools for lower income group population. And if there's a requirement, or in case there's only one school or one hospital on site, then lower income group population should be allowed to enter it with discounted prices, etc. And we've seen some cases where this is actually being implemented. So this is pretty common now, I guess. Planning also should consider adequate provision for informal markets. That means there should be dedicated space provided for informal markets. Infrastructure must be there, and which can then be used subsequently by people selling their goods over there, vegetables, fruit vendors, etc. But a dedicated space must be allocated for them. And the last component is food production on site. So plan your landscape so that at least 5% or 10% of the total landscape area is dedicated to food production. Now, this does not mean agriculture. This could simply be fruit-bearing trees or individual houses having organic gardens, etc. But a certain amount of food should be grown on site. Again, the original intent was to reduce the pressure on the surrounding areas as much as possible. So with that, we come to the end of the presentation. I'd like to apologize for certain glitches that were there in between. And we've managed to run very close to the time limit, but there was a lot to cover in this, and the time was short. And now hand it over to my colleague, Ankit.